Hey there, chemistry fans. Here we are to talk about a little bit of stoichiometry. This is number 7 off of your packet, and let's have at it. First thing you need to do with some stoichiometry is balance an equation. So I'm going to balance this with some 2's and 3's. That's imperative because without a balanced equation, you can never get your stoichiometry right. Now we have some information here, and eventually we want to know the theoretical yield of zinc oxide. Now, before we can do that, we need to decide how we're going to determine the zinc oxide quantity from the two different reactants that are shown. Now we have two different reactants, be it the 150 grams of zinc sulfide and the 150 grams of oxygen. And we have to make a decision on which one gets used up first by finding a limiting agent. So I start with my 150 grams ZNS. I'll put that over 1 and convert that to moles. And that's the molar mass. Remember, that's the addition of 1 zinc and 1 sulfur. I divide, and I get 1.54 moles. I can do the same with the oxygen, 150 moles O2, and that goes over 1. And let's use the molar mass of O2. And that will give us the grand total of 4.69 moles. Now, each of these, in turn, needs to be divided by their coefficient. Now, where do these coefficients come from? Our balanced equation. This 2 is where this 2 came from, and this 3 is where this 3 came from. Now, after we've done that division, the one that's the smaller is our limiter, and that comes out to 0.77, and the other 1.56. So here's our limiting agent. Now, that's really important. Remember, I get a point for deciding what the limiting agent is. I get 2 points for each conversion factor, and I get a point for my mathematics. So 6 total points credit for finding the limiting agent. That limiting agent is what we're going to use to find our theoretical yield down the bottom here. So now I'm going to start with 150 grams Z and S. And I'll put that over 1. Oh, it's fun. And then I say 1 mole over the molar mass of ZNS, which is 97.46 grams ZNS. And now here's my mole conversion. Here's where I do my comparison between what I have and what I'm looking for. So now I say 2 moles zinc oxide over 2 moles zinc sulfide. The third conversion factor converts me back to grams, so I have to use the molar mass of zinc oxide, which is 81.39. Then I press some buttons on my calculator. You'll notice that these 2's, in fact, cancel out right nicely. I end up with an answer of 125 grams, which with sig figs, according to what's up top, would be 130 grams ZNO. Now, when I want to find my excess reactant, I use the amount that I had for my zinc oxide, and I go backwards. So I'm going to find out how much of the ZNO, and I'm going to compare it to the oxygen. And so when I do that, I'll end up taking my 125 grams ZNO. You'll notice I used it without the sig figs. If you did use it with the sig figs, you'd still get the correct answer. I'd still honor that. However, you'd be skewing the answer a bit if we sig figged it over and over again. So I do go back to the original non-sig figged answer. From here, I say 1 mole over the molar mass of ZNO, which was 81.39. Now I have my mole conversion, in which I have 3 moles O2 according to my balanced equation, over 2 moles ZNO. And lastly, I convert back to grams, which is 32.00 grams O2 over 1 mole. And of course, I press some buttons and I get 73.7 grams. And that's how many grams of this were used. So now we need to subtract from 150 grams that we have. And when we do something like that, we end up with 76.3. And that's the amount of oxygen that we have left. Last but not least, let's find out the amount of excess, the percent yield. And so here we are saying that we only get 37 grams of ZNO. Well, we've just found, theoretically, the most possible, according to the conditions that were mentioned, we could get all the way up to 125 grams, which is quite a bit compared to 37. So we can take this equation that says actual over theoretical times 100 should equal the percent yield. And my actual, according to this, is 37 grams. My theoretical is 125 grams. And I multiply by 100. And I will get my percent yield, which comes out to 29.6%. Hope you enjoyed. Stoichiometry is fun.